Hello and welcome to this video. In this video, we will study 29th set of complex numbers. I have started creating slides for older videos. For example, I am preparing the logarithm uh, videos slides here. So these were the older videos, and slowly I will cover the slides from older videos to here. So for complex numbers, let's get back to our slides. So without further ado, let's get started. As always, I will say that when I am reading the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So question 281 says that show that the triangles whose vertices are Z1, Z2, Z3 and Z1 prime, Z2 prime, Z3 prime are similar if Z1, Z1 prime 1, Z2, Z2 prime 1, Z3, Z3 prime and 1, the determinant is equal to 0. So we know that from geometry, the triangles will be similar if all their angles are equal and ratio of sides as well. So we have taken two angles here. Argument of Z3 minus Z1 by Z2 minus Z1 is equal to argument Z3 prime minus Z1 prime by Z2 prime minus Z1 prime. And ratio of sides as AB by PQ is equal to AC by PR. Note that this R is this vertex. It is not related to the top triangle. So from this ratio, we have AC by AB is equal to PR by PQ, that is Z3 minus Z1 by Z2 minus Z1 is equal to Z3 prime minus Z1 prime, Z2 prime minus Z1 prime. So simplify these two equations and you will get your determinant. Question 282 says that if A, B, C and UVW are the complex numbers representing two triangles such that C is equal to 1 minus R into A plus RB and W is equal to 1 minus R into U plus RV, where R is a complex number, prove that the two triangles are similar. So from given equation, two equations we have, this should be equations. R is equal to C minus A by B minus A and R is equal to W minus U by V minus U. We equate these two equations, take modulus and argument, and like previous problem, we have the condition of similarity for two triangles. Question 283 says that find the equation of perpendicular bisector of the line segment joining points Z1 and Z2. So we know that points on a perpendicular bisector is equidistant from the 2 points of the line to which it is perpendicular bisector. Therefore, mod Z minus Z1 is equal to mod Z minus Z2. We square it and we apply the identity mod Z square is equal to Z bar. So we get Z minus Z1 into Z bar minus Z1 bar is equal to Z minus Z2 into Z bar minus Z2 bar. This equation can be written in the form of A bar Z plus AZ bar plus B is equal to 0, which is equation of a straight line. Question 284 says that find the equation of a circle having the line segment joining Z1 and Z2 as diameter. The midpoint of the diameter would be Z1 plus Z2 by 2. And we let P be any point lying on the circle which is represented by a complex number Z. Then the equation of the circle would be Z minus Z1 plus Z2 by 2 is equal to Z1 minus Z1 plus Z2 by 2. Note that this coordinate midpoint is the center of circle and this is on perimeter. The two endpoints Z1 and Z2 and Z is on the circle. So we have got two equations. We simplify and we have our desired equation. Question 285 says that mod Z minus Z1 by Z minus Z2 is equal to C. C is not equal to 0. Then show that locus of Z is a circle. So we substitute Z1 is equal to x1 plus I by 1 and Z2 is equal to x2 plus I by 2 in the given equation. which gives us mod x minus x1 plus I y minus y1 is equal to c into mod x minus x2 plus I y minus y2. We square this, we have x minus x1 whole square plus y minus y1 whole square is equal to c square into x minus x2 whole square plus y minus y2 whole square, which is equation of a circle. Question 286 says that if mod z is equal to 1, find the locus of the point 2 by z. So mod z is equal to 1, that means mod z square is equal to 1, that means z bar is equal to 1, that means 2 z bar is equal to 2. So we bring z to right hand side, we get 2 by z is equal to 2 z bar, is equation of a circle. Question 287 says that if for any two complex numbers z1 and z2, mod z1 plus z2 is equal to mod z1 plus mod z2, prove that argument of z1 minus argument of z2 is equal to 2 and pi. So we take polar coordinates here because arguments are involved. So we let z1 is equal to r1 cos theta 1 plus I sin theta 1 and z2 is equal to r2 cos theta 2 plus I sin theta 2. Then left hand side becomes mod z1 plus z2 is and left hand side is mod z1 plus z2. Yeah, we square it. We get r1 square plus r2 square plus 2r1 r2 cos theta 1 minus theta 2. And similarly, mod z1 plus mod z2, this should be z2 square is equal to r1 square plus r2 square plus 2r1 r2. So from left hand side and right hand side, we have cos theta 1 minus theta 2 is equal to 0, which implies argument of z1 minus argument of z2 is equal to 2 and pi. Question 288 says that find the, this is 288, this was 287. Okay. Question 288 says that find the complex number z, the least in absolute value which satisfies the condition mod z minus 2 plus 2i is equal to 1. So this can be a bit tricky to understand. I will repeat this question. Find the complex number z, the least in absolute value which satisfies the condition mod z minus 2 plus 2i is equal to 1. So we have this diagram z minus 2 plus 2i. So the x coordinate is 2 and y coordinate is minus 2, which is the center here. Now least value in absolute value. So least in absolute value will be this point P. Okay. So the line from origin which we will draw will make an angle of 45 degree. Okay. Therefore P would be 2 minus 1 by root 2 plus I 1 by root 2 minus 2. Because the radius is unity, if you move in this direction for unit distance, then x and y would be 1 by root 2. X would be minus 1 by root 2 and y would be plus 1 by root 2. If you draw a triangle here, the base would be minus, you are traveling left, so x would be minus 1 by root 2, you are going up, so y would be plus 1 by root. Find the point in the first quadrant on the curve z minus 5 is equal to 3 whose argument is minimum. So I think we have solved such a problem earlier also, where the center was 0, 25 and CP was 15, radius was 15. Yes, I remember that problem. So this circle is 0, 5 and this radius is 3. So if this angle is theta, then this angle will also be theta. Now this is 5, this is 3, so this would be 4. So CP OP would be 4. So theta would be, the tan theta would be, this is a tangent, so this is perpendicular and this is hypotenuse. So tan theta is equal to OP by CP, that is 4 by 3. Therefore the point would be 4 cos theta plus I sin theta is equal to 12 by 5 plus 16 I by 5. With this we come to the end of 29 set of problems. There would be close to 370, 380 problems. So another 7-8 days and we will be done with complex numbers. I hope that you have found this video useful and informative. Please subscribe to the channel, like the video, share as much as you want, and make use of the comment box to speak your mind. And I say this so that it motivates me, and it will make the video reach more people, because that is how YouTube algorithm works. Thanks a lot for watching. Have a nice day.